I would like you to read this question and to do it. See if you get the answer. I'll show you in a second. Okay, hopefully you pause the video. And the answer is 1.17 times 10 to the minus 2. Did you get that? Maybe no. I wouldn't have got that, to be honest with you. I think I would have got this answer, which is not bad, this one. If you did, you will get full marks. But why is it the main answer, this one? Well, what they do is they calculate the concentration of protons from the pH. That's it. And then they calculate the concentration of hydrogen sulfate, which is the same as the concentration of sodium hydrogen sulfate, because when sodium hydrogen sulfate dissolves, then the molar ratio is 1:1, so the concentrations are equal. Okay, so then they convert the milligrams to grams, divide by the MR, that gives you the moles, then you divide by the volume, which is 0.1 decimeter cube, which is equivalent to multiplying by 10. That's what they do in the mass game. It's a bit fancy, I know. And then they use the Ka expression. Now, what happens is this acid is not a common weak acid. It's a bit of a strong acid. How can you tell? Well, because the pH is low. It's 1.72. And therefore, it is what is called a strong, weak acid. Strong, weak. That seems a contradiction. Something in between a strong acid and a weak acid. You know that in life, you don't have black and white, you have gray. So this is gray. A strong, weak acid. How do you do the calculation? Well, then you do your initial amount. You do it as if it was an equilibrium question, which actually it is an equilibrium question. You have the acid. Initially, the concentration is 5.04 times 10 minus 2. And you assume you have no protons. The final concentration of protons at equilibrium is 0.0191. And therefore, the change, the reacted amount, is plus 0.0191 for the protons. And for the acid, it's exactly the same because the ratio is 1:1, but it would be negative. So your concentration at equilibrium is 5.04 times 10 minus 2 minus 0.0191, which is this value here. Then you substitute, and that's it. That gives you the Ka. All right, bye-bye.